Hello, my name is Matthew Perry, and I will be narrating the final presentation for our group's project, the Bowie knife design. My overall group was split into two different teams due to the competition we hoped to compete at requiring two different submissions. With that being said, Team 1 consisted of myself, Ryan Tim, Tommy Martin, and Tyler Albertson, while Team 2 consisted of Abigail Slocum, Morgan Thomas, Matthew Cornexel, and Ali Ashalati. The abstract regarding our project was that our group was tasked with manufacturing two functioning knives for the 2020 Cast and Steel competition hosted by the Steel Founders Society of America. The knives cast by each one of our groups will share the same steel alloy, but differ on design and the manufacturing method used for the production of the knife. Our sponsor for this project was Baycast, which is a large steel casting facility located in Bay City, Michigan, and our contact from this facility was Michael Graebner, who is the foundry manager at Baycast and was very helpful in determining what alloy and casting method would be best for creating our knives. As for a description about the competition itself, the basis of the project was to design and create a Bowie knife for both our sponsor Baycast and the 2020 Cast and Steel competition itself. This competition had rules regarding what the casting process is regarding the knife and the limits to the creation of the knife must be. And this included using modern casting processes, showing the design and process of these castings, using computer modeling, 3D printing, and additive manufacturing, showing our development regarding the alloy we chose and the selection process. The knife must have a 9 to 14 inch blade and also an integrally cast handle and guard. As for the background on casting in Bowie knives, casting is known as the process of heating a metal into a liquid and pouring it into a mold to achieve a desired shape. The oldest castings have been traced back to as early as 4000 BC, and sand molding started somewhere in the time around 645 BC. Metal casting came to the US in the early 1600s, and since then it has grown into a $33 billion industry which employs over 200,000 Americans. As for Bowie knives, Jim Bowie was the first to design the knife in 1830, while James Black was the first blacksmith to create the knife. Bowie knives were mainly used by U.S. troops in the Mexican War and during the Civil War by Confederate soldiers, with the popularity of Bowie knives rising again in 1950 due to its appearance in movies. As for our design process, it started out itself with Tyler, the PD and T major on our group, drawing these designs on sheets of paper, which were finally converted to a CATIA model once that we were satisfied that they would meet competition requirements. From there, the 3D model focused on ensuring the blade, guard, and tang were one solid piece and that everything was squared up properly. And between both of our knife designs, they shared the same overall length of 17 inches, as well as the same blade length of 12 inches, with the only major notable differences being the tang design and a slight blade alteration between the two designs. As for our QFD and material choice for the knives, our alloy choice was based off the QFD we created, which had the four characteristics regarded as most important. Those characteristics were toughness, edge retention, ease of sharpening, and corrosion resistance. While our design choice was created using the history of Bowie knife manufacturing to ensure that our final knife would meet the standards held by the contest to be considered an actual Bowie knife. The alloy we chose to use for our knives was CPM3V, and the chemical makeup of this alloy makes it very high in toughness and strong against wear resistance. It is designed to be a steel that provides great impact resistance and maximum resistance to breakage and chipping, which we felt would benefit us in the testing they did at the competition. Some of the common applications for CPM 3V are shear blades, scrap choppers, punches and dies, stamping or forming tools, and industrial knives. And once our alloy was chosen, we were then able to begin investigating which methods of manufacturing we would actually use to create these knives. And we decided as group 1 that we would use investment foam, and group 2 would use a match plate design. Uh, for the match plate, it is based off a model that was given to us from the mold flow program at Baycast, and a positive pattern will be milled out of a 1-inch plate of 6061 aluminum that was donated to us by Alro Steel in Clare. And because of this 1-inch thickness, the match plate is not thick enough to safely have both patterns on both sides. So due to this, we planned on milling positives of both the right and left side of the knives on separate, otherwise identical plates. We planned on having 2 knife patterns within each flask, and then having around 4 flasks total. Based off of the model that was given to us from the mold flow program, a negative will be moved into the aluminum cavity. As for the investment foam process, we'll be using the model again that was provided to us from Baycast regarding the mold flow program, and a negative will be milled into the same 6061 aluminum as the other manufacturing process. And this cavity will be filled with expansion styrofoam beads that when heated will expand to match the cavity, and this foam will then be used to build the sand around when packing the flask. As the zircon sand cures, the styrofoam can be removed from the mold, leaving us the negative that we are needing.